emerging infectious disease and threats to public health. Dave.
Thanks very much, Nathan. It's nice to be with you, and what I'm going to try to do is give you two scenarios and try to point out during those scenarios where the research issues are. And the first is really a very difficult and wicked problem because of the politics, because of the economics, and because of just plain lethargy in many cases. And that's antimicrobial use and its consumption in animals. Now, it's not only used in animals, and here you can see that about 50% of antibiotics are used in animals, sharing the same ecosystem with humans. And here you can see that it's not only in animals, it's also in fish, it's in fruit trees, it's in wherever you look. There are antibiotics being used to prevent bacterial infections in living organisms. And what we have is we have some evidence that when a resistant strain develops in either a human or an animal in zoonotic infections, the other part of that duo has a parallel infection. What's important here is to note the closeness in a zoonotic infection, Salmonella typhimurium, but also to understand that genetics show it's the same organisms, but who infects who, what infects what. Is this going from humans to animals to humans, or both ways? An important research question. At the same time, antimicrobial use in meat is very important, and you can see that the Scandinavian countries, as you would expect, have cleaner agriculture, and as a result they have less antibiotic going into their animal husbandry areas. And why are we interested in this? We're interested in this because these animal infections seed the human infections, or the human infections seed the animal infections. This just shows you the human-animal interface with many organisms that we're all familiar with, many of those resistant to antibiotic use, coming from the same ecological system. And as I said earlier, when antibiotics are used, they enter a system. They're used in both humans and animals, and then they enter into sewage systems, and if those sewage systems aren't what we want, they enter into the water and the soil and the environment, but also into the foods that we eat and everything else that we share with animals. And this is just one risk. Livestock waste materials being held in a waste holding lagoon pit, that then having the opportunity to penetrate into the soil and contaminate surface water and groundwater, and end up either resistant organisms or antibiotic residues in human populations. Now, as I said, the Scandinavian countries have been ahead of most other countries in dealing with this, and they've been able to show, very important to show the evidence, because this is an economic issue in animals, but they've been able to show that by stopping growth promotion, non-specifically adding antibiotics to animal food, they were able to increase they had to continue prescribing antibiotics, but at the same time what they saw was that they used less of them. So treating animals either with infection or prophylactically those around the animals is more economical, and at the same time uses fewer antibiotics. Norway developed some case scenarios to show that vaccination of salmon and trout would not harm the agriculture, and they could stop using antibiotics, which is what they did. And when they stopped using antibiotics, what happened was that their fish production actually went up because they were vaccinating these fish. They remained healthy. So again, lessons from Scandinavia, don't substitute sloppy agriculture. Don't deal with sloppy agriculture with antibiotics. In Denmark, again, macrolide use and enterococcal resistance in pigs. As antibiotic use decreased, resistance in pigs decreased. And again, in Quebec, the same thing. As they decreased cephalosporin in poultry, they were able to...
We are losing our most effective anti-malaria drugs. Millions of lives are at stake. The alarm comes from a world-leading center, the Shoklo Malaria Research Unit of Maezot, a Thai town on the Burmese border. Here, researchers are facing a strain of the malaria parasite resistant to artemisinin derivatives. This resistance makes these drugs less effective and could eventually render them obsolete.
SMRU, it's a field station of the Mahidol Oxford Research Unit in Bangkok, which is a collaboration between Oxford University and Mahidol University in Thailand. And it's doing operational research on malaria and providing healthcare to the population living on the border between Thailand and Myanmar. The resistance to artemisinin derivative was described around 2004 in Cambodia, and it started here between 2006 and 2008. It's only one of the parasites, Plasmodium falciparum, and we discovered it because as part of our research activities we follow the patients after treatment, and we noticed that when we treat them with these drugs, it took longer and longer for them to clear the parasite from their blood. And this is the first sign of resistance to these drugs.
About 70% of the parasites in this area are resistant to drugs. Researchers discovered it by checking a molecular marker.
So how long it will take to reach India and Bangladesh, we don't know, but we think it's a matter of only a few years. And unfortunately, there are some people, for example, at the WHO, who think it's not an emergency and that we have time to deploy, long-term strategy to deal with this. But our understanding is that it is an emergency, and that what we call the containment programs, which started in Cambodia to try to keep it in Cambodia, have failed, because now it's already here, and it's already in Vietnam, and it's probably already in Myanmar somewhere to the west. And if we continue to do the same strategy, then there is no hope that it will stop. So we must be much more aggressive to stop it.
What could happen if it reaches Africa?
Millions of deaths.
The clinics of SMRU treat 15,000 malaria cases a year, and these are the building blocks of their research. They also grow colonies of mosquitoes, and one of the scientists feeds them with their own blood.
Well, it's like acupuncture. It is painful, especially when you feed more than 500 mosquitoes. So, yeah, it's not pleasant.
SMRU is fighting the spread of the resistance by treating as many people as possible and increasing control measures. But this clinic alone cannot stop this spread.
What institution and government can do is to adopt policies and strategy which are aiming at eliminating malaria and not just controlling it. If we are not careful, we know that malaria will come back, because it has always done that. And if we are not successful in eliminating it, at least from large areas where there is a problem of resistance, then resistance will mean that those effective drugs that we have now, we will not have them anymore. And we don't have any new drugs to replace them. It takes about 10 years to develop a new treatment, and we don't have 10 years in front of us, so we need to do something about it.
Agradezco a la Universidad Nacional Autónoma de México y al Instituto Nacional de Educación Médica Continua la invitación a participar en este diplomado. Soy el doctor Andrés Tirado Sánchez, médico especialista de tiempo completo del Hospital General de México y del Instituto Mexicano del Seguro Social. El tema que vamos a tratar a continuación se refiere al uso de antimicrobianos de uso externo, pero además del uso vamos a hablar de otros aspectos como son las contraindicaciones, las combinaciones de antibióticos o de antimicrobianos y los principales mecanismos de resistencia que actualmente se conocen y que ocupan gran parte de la literatura mundial. El objetivo de nuestra presentación es conocer los principales antimicrobianos. No podemos abarcar todos, pero al menos los de uso más común y más cotidiano en nuestra práctica clínica, sus indicaciones, sus mecanismos de acción y los mecanismos de resistencia bacteriana, como los habíamos comentado, como objetivo principal de nuestra ponencia. De los antibióticos tenemos en realidad antecedentes históricos bastante amplios. Podemos comenzar con Alejandro Fleming, al cual le agradecemos el desarrollo de los antibióticos o del primer antibiótico que se pudo producir en masa y muy efectivo, ya que incrementó la sobrevida precisamente por ayudar a pacientes con infecciones severas o incluso infecciones incapacitantes. El desarrollo de los antibióticos ha pasado por diversas etapas. Estas etapas pueden incluir el uso de antibióticos que cada vez van aumentando su espectro de acción a llegar a ser antibióticos, como les mencionamos, de amplio espectro, para todo tipo de infecciones. Y un apartado pequeño, pero muy significativo, lo tienen los antimicrobianos de uso externo. Los antimicrobianos juegan un papel muy importante, sobre todo en el manejo local de algunas lesiones de la piel o de las mucosas. Son de uso común por dermatólogos y también de uso común por no dermatólogos y se consideran actualmente medicamentos de tipo OTC. Cualquiera los puede adquirir en cualquier farmacia sin necesidad de una prescripción y ese es el principal problema con los antimicrobianos de uso externo, al menos en nuestro país. Tenemos que el valor de los antimicrobianos de uso externo es limitado debido a la tendencia que tienen a sensibilizar. Esto lo vemos clásicamente con antibióticos como el cloranfenicol o la neomicina, que todavía en la actualidad los están vendiendo prácticamente sin receta, sin ninguna valoración médica, y eso nos puede afectar al momento de utilizar una contraparte sistémica. Por lo tanto, el antibiótico de inicio habitualmente debe ser un antibiótico que no tenga una contraparte sistémica y que podamos utilizar, y en caso de resistencia podamos saltar a un antibiótico probablemente sistémico que no nos va a generar tanto problema a la hora de tratar una infección.
Every day, thousands of microscopic processes occur within the body. One of these is the immune system's response to foreign cells. This bacterium has entered the body. Left unchallenged, it will replicate and cause illness. The bacterial cell carries unique antigens recognized by the antibodies on a B cell. Antibody receptors vary with every B cell. But when they match an antigen, the receptor sees it. Once the antibody takes hold of the antigen, the B cell engulfs the bacterium and the antibody. With the bacterium destroyed, the B cell becomes a professional antigen presenting cell. It presents a fragment of the bacterium on its own surface to alert other white blood cells. The cell approaching the B cell is a helper T cell. The T cell also has receptors that match the presented antigen. The T cell uses its receptor to connect to the bacterium fragment and B cell. This connection activates both cells. The T cell produces proteins known as cytokines. These cytokines will first induce the B cell to mature and produce many antibodies, which are released into the bloodstream. The cytokines then encourage the activated B cell to replicate itself, producing more B cells with the same antibody.